So welcome back. So we'll move to the next question. The statewide auto insurance company developed the following probability distribution for automobile collision claims paid during the past year. So you have a probability distribution. Set up intervals of random numbers that can be used to generate automobile collision claim payments. And also using these 5 random numbers, you have to simulate the payments for 5 policy holders. How many claims are paid and what is the total amount paid to the policy holders? So that we'll try now. Yeah. Fine? Yeah. So let us try. First of all, we'll construct the random number intervals. So this is your x. This is your f of x. So I should write here the cumulative, but I'm writing cumulative here. Cumulative probabilities. So first one is 0.83. The next one is 0.89. The next one is 0.94. The next one is 0.96. The next one is 0.98. Next one is 0.99. The last one is 100. This is for this. 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 83, 89, 94, 96, 98, 99, 100. Now we need random number intervals. So we always start with 0.00 to 1 below the number. 1 below means 0.82. Then again we'll start with 0.83. The next one is 1 below 89. Then again we start with 0.89. 1 below 94. Then again we'll start with 94. 1 below 96. Again we'll start with 96. 1 below 98. Again we'll start with 98. 1 below 99. Again we'll start with 99, 1 below 99. So this is the interval we got. Now what next? We have to simulate this experiment for 5 collisions. So I gave these 5 numbers that we see. So gave the random number. So the numbers are 7169. 2186, 2871, 9155, 1167. What you need to find? You have to payments for 5 policy holders. So you have to simulate payments. So 7169, where it is coming? 7169 is coming in the first interval. So payment is how much? 0. 2186. 2186 is also coming in the first one. So payment is 0. 2871 also comes in first. 9155. 9155 comes in third. So payment is 1000. 1167 comes in first, so again it is 0. So these are all the payments for the 5 collisions we have simulated. So like that, one can simulate any experiment in such a way. Any other queries? So how many claims are paid and what is the total amount paid to the policyholders? So here the 4 are no claims, only one claim is paid, that is $1,000, and total amount is 1,000 only. So in the examination we will give you random numbers for the uniformity of the answer. So no need to worry about how to get random numbers, that will provide in the exam. Only you have to simulate the experiment. So the only 2 steps involved in this process is, for a given x and f of x, just construct random number intervals. Then based on the random number intervals, for a given random number, you have to calculate x, that is payment fee. Any other queries? Then I'll move to the next question. A student organization surveyed both current student and recent graduates to obtain information on the quality of teaching at a particular university. An analysis of the responses provided the following teaching ability rankings. Do the rankings given by the current students agree with the rankings given by the recent graduates? So use alpha equal to 10% and test for a significant rank correlation. So now I am asking you rank correlation, right? So you know how to calculate rank correlation. So first of all, you have to calculate difference in rank correlation, DI. Then you have to calculate DI square. So 4 minus 6 minus 2, 6 minus 8 minus 2, 8 minus 5, 3, 3 minus 1, 2, 1 minus 2, minus 1, 2 minus 3, minus 1, 5 minus 7, minus 2, 10 minus 9, 1, 7 minus 4, 3, 9 minus 10, minus 5. Square it. So 4, 4, 9, 4, 1, 1, 4, 1, 9 and 1. So add it. 8, 17, 21, 22, 23, 27, 28, 37 plus 1, 38. So what is the rank correlation coefficient? RS is 1 minus 6 sigma d square by n into n square minus 1. That is 1 minus 6 into 38 by what is number of observations? What is the number of observations? Yes, 10. So 10 into 10 square minus 1. So please calculate, it's 10 into 10 square minus 1. So 10 into 90. So the answer is, so I have the answer, it's 0.77. Now you have to test it. So for test, what is H0? H0 is, so population rank correlation coefficient is 0 and alternative hypothesis, it is not equal to 0. So now you need to calculate the test statistic. So what is test statistic here? Test statistic is ZS. Z is equal to RS minus rho S by sigma of RS. So anyhow rho S is 0 under H0. So under H0. So what is the formula of sigma RS? I gave the formula. Square root over 1 by n minus 1. That is square root over 1 by 9. That is 0.333. So now you have to calculate the test statistic Z. So what is Z then? Z is 0.77 by 0.33. So answer is coming out to be 2.31. So now you have to calculate the p-value. So how do you calculate the p-value? So p-value is, so two-tail test twice of, yes, mu. What is mu? Twice of probability of Z. I am calculating for upper. Z greater than or equal to 2.33. That's it. So if p-value is less than alpha, we reject H naught. If p-value is greater than alpha, we fail to reject H. Yes. Not mu. Yeah, mu. Yes, you are right. Mu means what? Here, expectation of your random variable is RS. So expectation of RS is rho S, right? Sigma means sigma of RS. That is sigma, right? Yes. Any other questions? Yes, yes, yes. In the formula, Z is nothing but RS is your random variable. So RS minus its mean by its standard deviation. The mean of RS, that is nothing but expected value of RS, is always rho S. And sigma RS, that is the sigma you are talking about. Sigma RS formula is square root over 1 by n minus. Okay, any questions? I'm writing here for your convenience. You always think that if x is a random variable, what is z? X minus expected value of x by standard deviation of x. Here, what is your statistic? RS. RS is your statistic because it is calculated for the sample set of observations. It is your random variable. So, what is z? RS minus expected value of RS by sigma RS. That is RS minus expected value of RS means population rank correlation coefficient by sigma RS. That is RS, rho S is 0 by sigma. Yeah, any queries? Not rho S, because under H naught what you have assumed? Population rank correlation coefficient is 0. That is your H naught. Means there is no correlation in the ranks of the population. That is your H naught. Positive sentence. HA is not equal to 0. Means there is a correlation between ranks in the population. Yes. Good. Thanks. Shall I move further? Yeah. The gap between the earnings of men and women with equal education is narrowing but has not closed. Sample data for 7 men and 7 women with bachelor's degree are as follows. Data are shown in thousands of dollars. What is the median salary for men and what is the median salary for women? Use alpha equal to 0.05 and conduct the hypothesis test for identical population distributions. So do you remember which test we are going to use for identical population distributions? Identical population distributions. For identical population distributions, we use, yes please, we use Mann-Whitney U Test. Yes or no? Correct or not? For showing that the median of the two population distributions are same, we use Wilcoxon signed rank test. Yes, for yes, yes. You see, we have learned 5 non-parametric methods. One is sign test. It is for a single population median. Wilcoxon sign rank test. It is for the equality of medians of two populations. Mann-Whitney U test. It is for the identical distributions. Crystal values test. It is generalization of Mann-Whitney U test. Finally, rank correlation coefficient. That's it. So shall we try now? So yeah. So let us go to the question. So do you know what is a Mann-Whitney U test? Yes. So you have to give ranks. Correct. Yes, yes. So first of all, you have to calculate ranks for men and women. But ranks must be combined ranks, not individual rank. So check which is the lowest. So 29.1, this is 1. Then this is 2. Then this is 3. Then after 32, I think this is 4. After 4, where is 5? 40.4 is 5. Then this is 6. After 43, we have this is 7. After 45, this is 8. After 49, this is 9. After 50, this is 10. This is 11. This is 12. This is 13. This is 14. So you can take any candidates, either men or women. You have to add the ranks. So what is the ranks total here? 14 plus 4, 18 plus 9, 27 plus 13, 40 plus 6, 46 plus 11, 57 plus 12, 69. Then you have to calculate mu W. So what is mu W formula? You know, half into N1 into N1 plus N2 plus 1. So which is half into N1 is 7 plus 7 into 7 plus 7 plus 1. So answer is, I'm giving you directly 52.5. Then I'm asking you sigma W is square root over same formula 1 by 12 N1 N2 N1 plus N2 plus 1. That is square root over 7 into 7 into 7 plus 7, 14 plus 1, 15 by 12. So I'm giving you the answer 7.82. Right? Correct? Now you have to calculate the P value. So what is P value? Because you have to write first of all H naught. What is H naught? Both are identical. What are both? Both populations are identical. What is HA? Not identical. So when it is not identical, it is a two-tailed test. So it is probability is twice of probability of what is your test statistic? Double. Now you see average is 52.5. You got 69. So will it be 69 in the lower tailed or upper tailed? So if it is in upper tailed, then how do you calculate p-value? W is greater than or equal to 60. If suppose the total W is coming out to be 10, then 10 will be lower tail. So you calculate probability of W less than or equal to 10. But you know that twice into probability of W can be converted into Z greater than or equal to 69 minus mean is 52.5 by standard deviation. So p-value is less than alpha, we reject H naught. If p-value is above alpha, we do not reject H naught. Have you understood? So to check whether the populations are identical or not, we use Mann-Whitney U test. The process is simple. Write H naught, HA, just give combined rankings in which calculate the sum of ranks for one population. Yeah. When p-value is less than alpha, we reject H naught. Reject H naught means what? Both populations are not identical. When p-value is above alpha, we do not reject H naught. Means we cannot say that they are not identical. Yes? Shall we move further? Yeah. Then I'll move to the next question. This problem is a test was conducted for 2 overnight mail delivery services. 2 samples of identical deliveries were set up so that both delivery services were notified of the need for a delivery at the same time. The hours required to make each delivery follow. Do the data shown suggest a difference in the median delivery times for the 2 services? So medians of 2 populations. So whenever you are checking the medians of 2 populations, it must be Wilcoxon signed rank test. So whenever you are checking the medians of 2 samples, then it must be Wilcoxon's signed rank test. So what is the next one? This is Wilcoxon's signed rank test. So H naught is population medians are equal. HA is they are not equal. So process is what? For each pair of observations, calculate the difference. Then calculate the very good absolute difference. Then give ranks, of which calculate positive ranks. That's it. So difference is here 24.5 minus 28 is, I feel it is 3.5. This is 0.5. This is -4. This is 1. This is 1.5 with a minus symbol. This is 8. This is -4. This is -1. This is 0.5. This is -3.5. This is 1. Am I right? Then calculate the differences. So this is 3.5, 0.5, 4, 1, 1.5, 8, 4, 1.5, 3.5, 1. Just give ranks now for the data. So minimum, if you find any zeros in the difference, just discard the points. If you find any zeros in the difference, just discard the point. So starting is 0.5, 0.5, 2 are there. So you have to average first and second ranks. So here first and second ranks average, here first and second ranks. After that again you have 2 ones. 3 and 4 you have to average. So this is 3 and 4 average, this is 3 and 4 average. After that one, the next one is 1.5. So 1.5 I think you have only 1. So fifth. After 1.5 you have 3.5 are 2. 6 and 7. So 6.5. 6.5. Then next is 4s are 2. 8 and 9. So 8.5, 8.5. Oh yeah, you are right. There are 3 ones. I forgot. Then there must be a change. I'm sorry. Yeah, yeah. Thanks. This is 1.5. 3 ones are there. So 1, 2, 3, 4, 5. 3 ranks you have to average. So 3, 4, 5's average is 4, 4, 4. So 3, 4, 5 are over. Next 6th onwards you have to check. So tell me now which is the next number after 1? 1.5. So 1.5 is there. So 3, 4, 5 is over. This is 6. After 1.5, I think we have 3.5s are 2. 7 and 8 is there. So 7.5, 7. After 7 and 8, 4 is there. 9, 10. So 9.5, 9.5. Then I think this is 11. Got the point? So now you have to calculate the T plus, that is sum of positive ranks. So if you check the differences, 1 is positive, 8 is positive, 1 is positive, 0.5 is positive. 4 are there with positive difference. So what are their ranks? 1's rank is 4 plus 8's rank is 11 plus 0.5's rank is 1.5, 1's rank is 4. So what is the answer? Yes, please. So how much you got? 11 plus 8, 19 plus 1, 20.5. Yes or no? This is 0.5. This also I forgot. This is 1.5. Yeah. So one more 1.5. So how much you got? 11 plus 3, 14 plus 8, 22. So you got t plus s 22. Now you have to calculate the mean of t plus. So mu t plus is formula is, you have the formula n into n plus 1 by 4. So n is 11, 11 into 12 by 4. Then you have to calculate sigma t, t plus. So you should remember the formula, which is square root over n into n plus 1 into 2n plus 1 by 24. So then you have to calculate the p value. Correct? Correct? So you have to calculate the p value. P value is nothing but the two-tailed test probability of t plus is your test statistic. Now, what is sum of positive ranks? 22. Whether it is coming in the lower side or upper side. What? How do you check? Whether it is coming in the lower side or upper side. Because what is mean here? Mean is 33. So 33. So 22 is coming in the left side. So you have to calculate t plus less than or equal to 22. That is 2 into probability of t plus can be converted into z. Yes, sir. Where 22 is replaced by 22 minus its mean by its standard deviation. That's it. So then, if p value is less than alpha, we reject h naught. If p value is above alpha, we fail to reject h naught. That's it. Any other queries? Yes, please. Any queries in this problem? Yeah, I told you that if you want, I'll upload. There are 5 non-parametric tests. The first one is sign test. What do you mean by a sign test? It is used to check the population median for one population, or a matching sampling test that we did last time. The second one is Wilcoxon signed rank test. Wilcoxon signed rank test is used whether population medians are equal or not. Two populations here you are taking. Whereas in sign test, only one population and we are checking its median. Right? In third one, Mann-Whitney U test, we are checking whether the two populations are identical or not. Kruskal-Wallis test, not two populations, will say that 3 or more populations are identical or not. It is a generalization of Mann-Whitney U test. And fifth one is rank correlation coefficient, we did it. So, any other queries? So I'll close with the last question. This is sign test. Are stock splits beneficial to stockholders? SNL Financial studied stock splits in the banking industry over an 18-month period. For a sample of 20 stock splits, 14 led to an increase in investment value, 4 led to a decrease in investment value, and 2 resulted in no change. When there is no change, you have to discard these 2 from the sample. So sample becomes 18. Conduct a sign test to determine if it can be concluded that stock splits are beneficial for holders of bank stocks. So what are the null and alternative hypotheses? Using alpha equal 0.05, what is your conclusion? So let us try this question. Fine. So how do you try this question? So we have to discard. So H naught always in sign test. P maybe sometimes is equal to, sometimes not is equal to, less than or greater than something we should write. Conduct a sign test to determine if it can be concluded that stock splits are beneficial to for holders of bank stocks. So beneficial means what you will write. So generally the logic is what you are going to test, it should be in HA. So beneficial means should be greater than median, right? And the other one is obviously less than R. So now what is your sample size N? So we reduce 2 because no change. So remember is 18. So how many are there above median? So plus signs. Above median, how many are there? 14 are increasing. And how many are there on negative signs? Is correct. 4. Now you know very well that your test statistic, that is your test statistic is positive signs in the population is follows binomial, correct? With parameters N is 18 and P is 0.5. Now you have to calculate the P value. So how do you calculate the P value in the binomial? So P value is, it is an upper tail test, no need to double it. So X, so I'm talking about positive signs. So they are 14. So obviously when you talk about the error, it should be to the right tail. So X is greater than or equal to 14 because it is an upper tail test. You have to take X greater than or equal to 14. So now we want to use this. I cannot use normal because sample size is very small. You have to use the binomial. How do you use binomial? Convert them into CDF. 1 minus probability of X less than or equal to 30. So let us see whether we can do it or not from the table. Because under null hypothesis, small p is 0.5. That's what the concept of sign test, right? What do you mean by sign test? Sign test means H0 and HA are defined in such a way in terms of small p. So let us see the binomial. 18 is n and p is 0.5. So this is binomial. 18 is n and p is 0.5. So 0.5, p is 0.5, I think. Yeah, this is 0.5 here. N is 18. Do we have 18 here? Yeah. So 0.5 is there, P, N is 18. So what number I am asking you here? 13. Less than or equal to 13 means, you see 13. So 13 how much? 0.0327. So you just write here 0.0327. Just a moment. Whether we have done in the correct way or not, let me check. Because I have a small query with the table. So what type of probabilities it is calculating? N is 18, 13. Let me check the figure. Okay, it's only giving not CDF. It is giving only probability mass function. So then it will be difficult. So you have to take care of that. Yeah. So then it's very difficult for us. The table is of different kind. So this is wrong. So we cannot use because our table consists PMFs. So you have to calculate at 15, at 16, at 17, and at 18. So 15, 16, 17, 18. Okay, I think you can add 14 also. So you have to add 14, 15, 16, 17, 18. So here you see 14 is 0.0117. These 4 you have to add. 1, these 4. These 4. 0.0117 is 14, then 31, then 6, then 1. If you add them, how much you are getting? 1 plus 6, 7, 31 plus 6, 37, 0154. So if you add them, you got 0154. So this is 0.0154. Right? So just compare p-value with alpha. So if it is less than alpha, we reject H0. Otherwise, we do not reject H0. So any other queries? Hope you might have understood all these problems. These problems are important for our comprehensive exam. So just revise all these problems, like these type of problems, the same models rigorously. Okay, thanks. So any other queries? So I'm closing it now. It's time up. Yeah, thanks. So all the best. So we have completed our course. So this is the last lecture. Yes, only concentrate on the problems which I have explained you. Like today's problems. The same type of problems you remember. Sure, I will try. Okay, then. I'm just repeating one more time. Please prepare the models which I have discussed you today. Yes. Whatever models I have discussed today, the models are important for comprehensive examination. We have discussed 9 different problems today. So those 9 problems models are important for compre. Please put a mail. It's like somebody is waiting outside for another class. Please. Yeah. Thanks. So I'm repeating. Please prepare all those 9 models today I have discussed. They are important for compre.